Hello, everybody. Uh, I'm Murali Krishna Tulasiraman. I'm going to present today about simulation and validation of smart shared parking services using Eclipse ecosystem. I was then a master student when I was doing this project, and I did this as part of work as part of a master thesis student in ITMS, and now I'm presenting the results and findings in the project. First of all, this project is about to analyze and solve the existing parking problem in the real world scenario. Like for example, if I park a vehicle in a certain location in a destination, I'll have to travel to a certain distance to reach the to park the vehicle and then come back to the destination. So this is an existing real world problem. So there are many solutions offered as part of this uh, to solve the problem. So one of such model is shared parking model. And the motto of this particular work is to analyze the shared parking model and the benefits of it. So there are two important terminologies associated with this particular uh, project. One of such thing is SmartGate. SmartGate is a proposed hardware by ITMS, which is an electrical garage device that is capable of sensing and actuating signals. And with it is proposed to be equipped with a vehicle to everything communication framework so that it could communicate with the nearby devices that is capable of such communications. So it could communicate with a nearby roadside unit or like a web service and such a thing. So this SmartGate hardware along with the vehicle and cloud-based web service forms the VANET. And yeah, this is a basic norm. In this is a basic uh, thing that is like that forms the background of this particular project. So in this particular work, uh, the main contributions are to set up a simulation based test bed so that the so that we could vary the actual scenario setup, and we could make some system design changes and obtain output and logs in data based on which we could do further processing and inference, and which will make us to conclude some important inferences. Uh, the limitations of previous works are that the entire conclusions of the shared parking model and related mathematical models were based on a mere survey. Uh, so real world simulation might be necessary to conclude the actual inferences. So to overcome those limitations, we have aimed at a simulation based setup for a real world scenario. So now comes the system design and architecture. The entire work is based on Eclipse MOSAIC. Eclipse MOSAIC is a co-simulation framework with different simulators, primarily based on Eclipse SUMO, and there are several other simulators like uh, uh, Omnet++ and NS3, which are of same, like to simulate the network communication in the between the components in the network, say a car to car communication or car to the nearby roadside unit and such units. So so I'm sorry. So this particular in this particular work, we have taken out a part of uh, a network part of the Dublin city, and we have converted into a SUMO network using the uh, APIs provided by Eclipse MOSAIC. So in the left hand side, you could see the OpenStreetMap version, and in the right hand side, you could see the SUMO network version of it. And these are the demand data survey points, and the demand data survey points denotes the uh, different points in the same network where uh, the number of vehicles going in and out of this city are sensed. Uh, though there are many entry points in this particular network, we just consider a particular point in the work. So those are like the points 30 and 31. And this particular data is extracted from the dataset provided by the Dublin City Administration. And thanks to them. And then comes the design of the system. So there are two mathematical models involved in the system design. So the first mathematical model uh, focuses on the preferred walking distance of the driver. So this particular focus is to consider the preferences of the driver who could consider to park a vehicle at a certain point and then travel to the actual destination. And so apart from that, we also consider the timings and also the availability of the parking spots, and and also the second mathematical model focuses on the revenue. So it considers the actual revenue generated for parking for a certain duration, and in addition to that, as a penalty for parking overtime, the parking lot owner gets an additional revenue from the driver. So it focuses on that. The different parts of the mathematical models explained in the previous slides are put into different modules in the web service, and this gives the notion of the web service hosted shared parking private parking model, uh, which would be communicated which would be accessed for the parking requests done for each vehicle. So for example, the module distance manipulation focuses on calculating the uh, uh, distance between uh, the parking lot and the nearest and the actual destination of the vehicle. And this would be achieved by a routing service called open source routing machine that calculates the real-time distance between the parking lot and the actual destination. So this represents the data flow between the components. So when a car driver requests for a parking, it goes to the roadside unit, which is the actual smart gate device. The notion in this particular project is that the smart gate device, which was explained earlier, access the roadside unit. So different roadside units deployed at different parts of the network are the smart gate devices, and this would be capable to serve the particular parking lot owners, and also at the same time the others in the considered network. So yeah, and once the parking request gets to the roadside unit, it gets communicated to the web service where the different modules are hosted, and it gets the suitable parking lot for the driver, matching the other preferences, and then it is communicated to the car driver back. Similarly, when a car driver prefers to resume the operation from the parking lot, uh, the related calculations like how the duration he has parked and things like that is calculated. So The entire notion of this particular work is that we focus on the shared private parking model, where the residential parking lot owners uh, could generate revenue, and also at the same time there is a competitive pricing scheme for the uh, there is a competitive pricing scheme which enables the drivers to have access to the cheaper parking spots in addition to the commercially available ones. So the results are based on benchmarking the comparison between the operation of parking model with just the commercial parking lots, and in addition to that uh, another model with by comparing the parking model with just the commercial parking lots with that of the model with the commercial parking lots and the shared private parking lots. So So to do that, we have considered such a metrics. Um, so the first metric is the vehicular communication. So how it gets affected with the increase in the number of shared private parking lots, and how the reroutes, say a vehicle is rerouted in a real-time scenario, like say in a real-time scenario where there is a digital board display where the vehicle gets redirected to another when there is a when there is no parking spot available. And also distance travel, um, the additional distance traveled in search of parking lots. So the next metric is the utilization rate of parking lots, where it denotes like how much the shared private parking lots are used in whole when compared to the commercial parking lots. And then the revenue, which is almost proportional to the utilization rate of parking lots. And finally, there is a correlation heat map that says how each and every metric is affected with the increase or decrease in the number of shared private parking lots. So uh, the first aim of the work is to construct a simulation based setup so that this facilitates uh, changing the system design and analyzing the effect of it. And for that, we have the V2X framework, Eclipse MOSAIC, with different components deployed on it. And in parallel, we have a web service that hosts the shared private parking model. And then from the vehicular communication framework, we get the vehicular emission log, and the web service, we get the database records, and which in turn gives us the utilization and revenue logs. And based on these, we compare and process and consolidate the data. We perform two types of analysis. One is comparison analysis, and the other one is a correlation analysis, which helps us to give some important inferences. So first of all, we have had a minimalistic scenario where we had only 76 vehicles, out of which only 20 were searching for parking spot. This particular part is to analyze the effectiveness of employing a communication strategy while searching for a parking spot, say the vehicular communications strategy, or it could be a cloud-based ones based on the cellular communication, where the recent 5G techniques. So on analyzing this, while the model without communication uh, emits the average emissions during uh, when employing a model without communication is much larger than that of the model with communication. And obviously there are no reroutes in the model with communications, because the location and access preferences of the parking lot are already communicated to the user in advance. So next comes the benefits of the shared private parking model to vehicular drivers. So uh, The in this particular graph, we have three scenarios where we benchmark the parking model with just the commercial parking lots, with the model with communication with I'm sorry, we benchmark the model without commercial parking lots with the model uh, which has both commercial and shared private parking lots. So in the first part of the graphs, we have uh, 24 shared private parking lots, and in the second scenario we have 28 shared private parking lots, and in the third scenario we have 32 shared private parking lots. So with the increase in number of shared private parking lots, the vehicular emission decreases, and with the and also uh, another thing that I missed is that the stem in the graph denotes the distance traveled by the vehicle in average in search of a parking spot. So with the increase in number of shared private parking lots, it's evident that the uh, distance traveled in search of a parking spot decreases. These are the inferences in terms of numbers. Uh, as we can see, the mean vehicular emission decreases with the increase in number of shared private parking lots. Then comes the utilization rate. Um, uh, this denotes how the shared private parking lots are utilized when compared to the commercial parking lots. Here we could see that the utilization of a particular commercial parking lot is a lot more than the others, because this is to the strategic position in the network, in the SUMO network. So with the increase in number of shared private parking lots, we have like the increased utilization, and there is a reduction in the gap between the utilization of um, a commercial parking lot that is being utilized more in the shared private parking lots on average. And this is an and this is related to, this is the correlation, and this is the result of a correlation analysis. And here the important parameters to consider are the ratio. The ratio denotes the number of that denotes the ratio between the number of shared private parking lots and the number of commercial parking lots. So we will analyze how the other parameters are affected with the increase or decrease of the number of shared private parking lots. So the first correlation to consider is the ratio versus vehicular emission. So it is minus 0.32. So the correlation is that, like, with the increase in the number of shared private parking lots, the vehicular emission considerably decreases. And the next important parameter to consider is the redirects. When considering the redirects is the parameter that denotes the number of vehicles that leaves out of the shared private parking model and goes the conventional way to get the parking spot. So in that, the number of redirects decreases with the increase in number of shared private parking lots. So yeah. And then comes the amount of vehicles that are served by the shared private parking model instead of leaving out of the model. So that considerably increases with the number of uh, shared shared private parking lots. In conclusion, this particular work is to prove the effectiveness of the existing shared private parking model, and And this is of course an improvement to the traditional model by proving lesser emissions and things like, and offering competitive pricing scheme. So for this, we have a comparison analysis and a correlation analysis. And the correlation analysis helps to conclude the reaction of vehicles and model. Uh, there are certain aspects that are out of scope in this particular work. Um, so the first one is like uh, we need to ensure better scalability, where changing the scenario would be could be done and could be done with more ease. Uh, there could be better route planning and route planning between the vehicles and the parking lots and the vehicles reaching the destination things. And there could be a better parking and overtime parking behavior model. As of now, some of the vehicles were destined to be parked overtime, but this could be improved by employing a parking overtime model, parking behavior model. And there could be better standardization of V2X messages in this particular work. For now, we are just using a standard unicast message scheme and things like that, but we could improve by better standardizing the V2X message destined for this particular ad hoc messages and ad hoc services like parking. So this particular work could be extended to a larger city-based scenario to analyze how uh, uh, such a model would affect. And there could also be a digital hardware in loop simulation or a digital testbed setup. And then um, we could have bike travel as an intermodal travel option, whereas now we have the walking as an intermodal travel option. Yeah, that's it from my side. I'm stopping the sharing. I'm open to questions now. Uh, there is a first question. Uh, there is a comment that like it's a very interesting approach. Thank you for that. And the question is that, are there already any plans to deploy and test this in the real world? Yeah, there is a plan, but we haven't actually progressed to that stage yet because there are some scalability issues to be resolved, and then yeah, we could do that. Does that answer your question? Okay. Okay. If there are questions, if there are no questions, then yeah, I'm signing off. Thank you. Thank you for listening to the presentation, and thank you for the opportunity.